Good morning, everyone. Today we are going to discuss about the basics of laser. In this lecture, I'm going to talk about first introduction of laser, then properties of laser, stimulated absorption, spontaneous emission, and stimulated emission. So let's start with the laser basics. So what is basically a laser? Laser is acronym of light amplification by stimulated emission of radiation. Now see, what is a laser? Laser is a device in which we amplify light with the help of stimulated emission, or any light source in which we are amplifying the light with the help of stimulated emission is known as laser light. And laser is one source which is highly coherent, monochromatic, unidirectional, means these are some of the properties of laser. So if any light source has this type of properties, we can call it as laser light. So basically, what is the meaning of light? Light means number of photons. Amplification means we have to increase something. Stimulated emission is the phenomena which we have to use, usually such as, for example, light bulbs, tube lights. In this, we don't have the stimulated emission. So they are ordinary sources of light. But in case of a laser or any device in which we have stimulated emission phenomena, that is a laser source. Off radiation means it can be UV, it can be visible, it can be IR radiation. So in any light source in which we are amplifying light with the help of stimulated emission, that light source is known as laser light. Now, this is the principle of the laser that is known as stimulated emission. Keep in mind, and I'll discuss later on what is the meaning of stimulated emission. Then we have the concept of stimulated emission. The concept was given by Albert Einstein. Actually, what happens in any light source, what is the requirement? There is a ground state in which we have atom and there is excited state. So whenever you supply some energy, atom go or electron goes from ground state to the excited state. When it comes back from the excited state to ground state, there is emission of a photon. So we call it as emission and absorption phenomenon. But in case of laser, there we have third phenomena, which is known as stimulated emission, and this concept was given by Albert Einstein. Then we have in 1954, according to based upon this concept, Towns and Gordon developed a measure using ammonia. This is also a kind of amplifier, but in this we are amplifying microwaves. Basically, full form of measure is microwave amplification by stimulated emission of radiation. Using the concept given by the Albert Einstein in 1960, man developed Ruby laser, which is an example of solid-state laser. In 1961, Ali Javan and his co-worker constructed helium neon laser, which is an example of gaseous laser. So we have different type of laser: solid-state laser, gaseous laser, liquid laser. Okay. Now, what are the properties of laser? First property of laser is unidirection. Uni means single. Direction means movement of photons in a particular direction. So in case of a laser, photon travel in a particular direction in a single direction. Can you see from here? Okay. So unidirection means the photons move in a particular direction. But if you look at an ordinary source of light, photons move in all the directions. So if we have to differentiate between laser and ordinary source of light, you can say that in case of a laser, photons travel in one direction. But in case of ordinary source of light, for example, bulb, photons move in all the direction. Then we have monochromaticity. Mono means again single. Chroma means color. So whenever we talk about color, it simply means we are talking about wavelength, we are talking about frequency kind of things. Okay. So in case of laser, they have single wavelength. So every time you will see a laser in a particular color, it can be in red color, blue color, yellow color, but it cannot be in white color. Okay. So if you look at a bulb is a combination of so many colors. Okay. If you see a fluorescent bulb, it is a combination of red, blue, and green. Then we have high intensity. What is the meaning of intensity? Intensity is measured as power per unit area. So laser lights are uh, highly intense in nature as compared to the ordinary. If you look at a 1 watt laser and if you look at a 100 watt bulb, and this is 1 watt laser, so you will see that 1 watt laser is highly intense as compared to 100 watt bulb. Then we have coherence, and this is the main property of laser which makes them laser. That is the coherence. Whenever, let's suppose you have two waveframes or two photons, okay, if they're traveling in the same direction, they have constant, you can say, phase difference, they have wavelength, they have frequency, they have same amplitude, that is known as coherence. And in case of this laser, coherence is high, so which make them as coherent source of light, and ultimately they are called as lasers. So these are the four properties, main property. First is unidirection, second is monochromaticity, third is high intensity, and fourth one is high coherence. Now we have emission in laser. How we have emission? So the first phenomena is stimulated absorption. Keep in mind, sometimes stimulated is also known as force process. Okay. So whenever you have to supply some energy from the external source and you have to supply some energy force such that a process happens, that those all phenomena are known as stimulated. So what is the meaning of the absorption? So we know that in case of any atom, you have ground state and you have excited state. So in the very starting, atoms are in the ground state, okay? Because ground state is a stable state and atoms do not want to go to the excited state. So what happens? So atom, as you can see, atom is in the ground state, but we want emission. So this atom has to go in excited state. So as it has to go in the excited state, we have to supply some energy. Okay, so we incident external photon, which is having energy, you can say h nu, and this energy is equal to difference of these two states. Only then this atom can absorb energy and can jump to the excited state. Okay, and this is also represented by the symbol delta. So if you're providing this much energy to the atom in the ground state, so this atom will absorb the energy and it will jump to the excited state. This phenomena is known as stimulated absorption. And what is the probability that this atom can go from state 1 to this? That is directly proportional to energy density. And if you remove the proportionality constant, it will become B12 into U. What is B12? B12 is Einstein's coefficient of stimulated absorption. Now, when you supply some energy, so there is emission, but there are two types of emission process in any source of light. So initially, now the atom is in the excited state, okay, because you have supplied some energy, which is the difference of E1 minus E2. Now, atom is in the excited state. If the lifetime of the atom is in the excited state, that is equal to 10 raised to the power minus 8 seconds, it will come back to the ground state by itself. This phenomena is known as stimulated emission. When this atom will come back to the ground state, it will emit a photon which is having energy h nu, and this photon doesn't have any direction. It means it can be in any direction or so in any direction. So this phenomena is not responsible for the laser action. The spontaneous emission is also known as random emission. Why random emission? Because the atom is coming back to the ground state by itself with the emission of a photon in which it doesn't have any direction. Since it doesn't have any direction, so obviously there are a lot more photons in the system, lot more atoms in the system, so lot more photons in the system. So that source of light is not known as laser light. So what are the example of the sources in which we have spontaneous emission? That can be bulb, that can be tube light, and that can be sun. So this is what happens in case of after emission. And spontaneous, what is the condition of spontaneous emission? 10 raised to the power minus 8 seconds. Okay. And how will you decide that this spontaneous emission will happen? This is equal to A21, and A21 is known as Einstein's coefficient of spontaneous emission. And this is also a coefficient, and this value is equal to 1 by tau 21. What is the tau 21? Tau 21 is lifetime of atoms in excited state. Okay, so let's suppose if they are staying in the excited state as 10 raised to the power minus 8 second. So what is the value of A21? This is equal to 10 raised to the power 8 second inverse. So this is the rate by which the atoms are coming back to the ground state. So this is known as spontaneous emission. The next emission, that is the responsible for the laser action, or known as the principle of laser, that is known as stimulated emission. And what is the condition for stimulated emission? If atom is in the excited state and it has lifetime in the range of 10 raised to the power minus 3 to 10 raised to the power minus 6 seconds, that is known as stimulated emission. Okay, but when does it happen? What is the first condition is that 10 raised to the power minus 3 to 10 raised to the power minus 6 seconds. But what happens in case of stimulated emission? This atom is triggered by external photon. We have to incident external photon, and let's suppose its energy is equal to h nu. So this atom then come back to the ground state with a photon which is having the same direction. So incoming photon and outgoing photon both have the same direction. So now you have two photons in the system and both are in the same direction. Okay, they have same amplitude, they have same energy, same wavelength. So that is known as coherence. Okay, and that emission process is known as stimulated emission. So now look at this. So if it is the stimulated emission and the lifetime is 10 raised to the power minus 3 to 10 raised to the power minus 6 seconds, so this atom is triggered by this external photon. So as a result of this, there are the emission of 2 photons. Although there is emission of only 1 photon, but we have represented this photon over here as well. So these 2 photons are in the same direction. Okay, so that is known as stimulated emission. And this is the principle of laser action. Now, in conclusion, what we have this. So first we have atom in the ground state. You supply some energy. Okay, it goes to the excited state. Once it is in the excited state, okay, there are 2 processes. One is known as spontaneous emission, another one is known as stimulated emission. What is the condition for spontaneous emission? 10 raised to the power minus 8 to 10 raised to the power minus 9 seconds. So if the atom has this much time in the excited state, it will come back to the ground state by itself. Okay, but if the lifetime is in the range of 10 raised to the power minus 3 to 10 raised to the minus 9 seconds, so it will come back to the ground state, okay, with the emission of 1 more photon, which is having same energy as the incoming photon. So total emission, which is sum of equal to spontaneous emission plus stimulated emission, is equal to A21 plus U nu B21. And what is B21? B21 is Einstein's coefficient of stimulated emission, and U nu is the energy density of that photon. And this absorption probability is equal to P12 is equal to B12 into U. So at equilibrium, P12 is equal to P21. So absorption is equal to spontaneous and sum of spontaneous plus stimulated emission. Keep in mind, in case of a laser, there are chances that 5% chances of spontaneous emission and 95% chances of stimulated emission. So that's why lasers are known as ideal source of coherent light. Okay, they are not 100% coherent in nature because there are chances that we have spontaneous emission as well. So this is all about laser fundamentals. Thank you, everyone.